Okay, we're good. So we were only supposed to do 1 through 4, right? And then
Yeah.
Yeah, I think
Before.
so.
this one's a little bit more confusing to me.
Well, worst case scenario, we can still just like do 5 really quickly or something.
Okay. I don't have the key up. I guess I should get that. Unless somebody else has it.
I have it up. It's okay, and she has it too.
Sweet. Okay. Um, one says, one says this question concerns the components of black opera. A, what two regulatory functions are involved in black operon? That's the cap protein and the lac repressor, right?
Mm-hmm.
I have a hard time remembering all of these, and they're different.
Yeah, I do too.
He asks what two vector molecules are involved in regulating the lac operon. I said this in the inducer.
I didn't catch any of that. What?
He says, what two effector molecules are involved in regulating the lac operon? And I said CAMP in the inducer. I don't know if that's right.
What is it? I can't hear you. I don't know why,
Like I heard I heard just read the question, but I couldn't hear you like your answer. I
Okay.
heard CAMP from you, but
The CAMP, and then I said the inducer.
okay. On the key it says it's CAMP, so you're right on that, but it also says allolactose, not reducer.
Oh, okay. So let me put the next one. Oh.
Mhm.
no. Are we? I thought we were talking about for A.
No,
No.
we're on B.
Oh.
A was the CAP, the cap protein,
Oh, okay.
the lac
Yeah.
repressor. And then C says, what four DNA sequences are involved in regulating transcription of the lac operon? So I said the cap site, the lac promoter, the operator site, and the lac terminator.
Yeah.
Mm-hmm.
Yep.
Awesome. Are you getting this, Jennifer?
Yeah.
Do you get this?
Am I understanding this?
Yeah.
Not really, but
This one was
some
kind
of
of
them.
hard.
Yeah.
But it's also like if you just read the instructor notes and like it's pretty much the same as like the last 3 weeks.
Yeah.
It's like all this stuff about promoters and the operator and the terminator, like it's like in that order, but
Like, in order to prep for the test, I feel like I need to just read through everything again, like everything, and watch all the videos again.
yeah.
But
Same.
Um,
okay, so D says what three structural genes are found within the lac operon? I said the lac Z, lac Y, and lac A.
Mm-hmm.
Yep.
yeah.
All right, who wants to do two?
I can do two. Suppose we isolate an E. coli strand that produces an inactive lac repressor protein that cannot bind to the operator sequence of the lac operon. What happens to the expression of lac operon genes? This is probably just going to come straight from the key. An E. coli strain called the lac L negative produces an inactive lac repressor protein that fails to bind to the lac operator sequence. This lac L negative strain displays constitutive expression of the lac operon. The lac operon is described both in the absence and in the presence of lactose.
So the lac operon is still expressed.
I think so, yeah.
Yeah. So what I put, because I put it similar to what the key had, but like I reworded it kind of, if that makes sense. Like I wrote it so that I could understand it because the key is really confusing. So for mine, I just put this as an example of constitutive expression. The lac operon gene will still be expressed and transcribed whether lactose is present or not. With an inactive repressor, the frequency of transcription should increase. Because that's what happens when you have an inactive repressor.
That makes sense because the repressor would repress the activity. Right.
Yeah.
Mm.
Yeah. So your transcription frequency is going to increase, and then if there's lactose present, it's still going to get transcribed, and the gene will still be expressed.
Right.
But if it's whether it's there or not, it doesn't matter.
Okay.
Hmm. Okay. Do you guys want me to read the key for 2B then?
Yeah.
Sure.
Okay. Is this advantageous or disadvantageous to the cell, and why? They give a big old paragraph. Constitutive expression of the lac operon is disadvantageous to the cell. If the lac operon is transcribed continuously, then the enzyme B-galactosidase, sorry, I can't pronounce anything today, lactose permase, and galactoside transcyclase are produced even when lactose is absent. Translation is a very expensive process in terms of cellular energy. By producing these enzymes even in the absence of lactose, the cell wastes 1 ATP per amino acid and 2 GTPs per amino acid and a final GTP to terminate translation for each copy of these 3 enzymes. So basically, it's like just using a lot of energy if it just keeps going.
Yeah, because you have to produce all those enzymes when if the lactose isn't there and you're producing a bunch of enzymes and you're using energy to produce enzymes and then you're using energy for those enzymes to go break down that lactose, like you're just wasting energy and you're wasting cell materials and there's not even any lactose there, like, for it to make a difference, so.
Okay. Don't know if I fully understand that, but I need to go look at the key and then I'll replay this video.
Okay. Basically, it's like because so the lac operon
Energy used.
produces the enzymes to break down lactose.
Uh-huh.
Lactose is a sugar that we normally can't digest
Uh-huh.
without those enzymes. So if the lac operon is like doing all the transcription for those enzymes, like to produce those enzymes,
Mm-hmm.
if lactose is not present, so there's no lactose there, but the lac operon is still making those enzymes, then you're just like wasting energy making enzymes to try to break down a molecule that's not even there.
Okay. That does.
Does that make more sense? Okay, I know it's confusing, but yeah.
All good. I mean, it makes sense. It's just a lot of the same. Like the words are the same,
Yeah.
so that's what. It's just like sometimes you have to break it down and kind of like follow the trail. But
Hmm.
They just give really long-handed explanations you get lost in, or at least I do.
And they're so like specific when, I don't know, I think it's easier to simplify it. Okay, I'll read number 3. So, in the lac operon, how would gene expression be affected, inducible, non-inducible, or constitutive, if one of the following DNA sequences were defective? So, A, if the lac promoter is defective, then the lac operon is non-inducible. And the key says, in a lac promoter mutant strain, sigma factor and RNA polymerase cannot bind to the promoter, whether or not it doesn't matter whether not lactose is present. It can't bind. Those can't bind to the promoter, so it's non-inducible. For B, for the operator site, it's the lac op. Wait, what? Oh, is that you? Bell's background noise? Okay, I'm like, I can't tell because I'm not watching, I'm reading. So the second one, operator site, is constitutive. And this one says the lac repressor cannot bind to lac-O under whether lactose is present. Goodness, there's so much going on. in a LAC-O-C strain.
Okay, hold on a second.
I don't want to be here. I don't want to be here.
Yeah.
Rambo, Terminator.
Okay, sorry guys. No, I'm in the middle.
It's rated.
I don't know if I should be worried.
Okay, go ahead.
Is the dog okay?
It's okay.
The dog's fine.
It's not the only person I care about in this. Just kidding.
Almost excited.
Okay, go ahead.
Okay.
So we're going on another with this extra money.
Oh my gosh. Okay, so it says therefore sigma factor. Am I on the right one? So yeah, sigma factor and RNA polymerase can bind to LAC-P either when lactose is absent or when it's present. For the LAC-Y gene, non-inducible. And yeah, it just basically, I don't know, there's like all these super long and exciting explanations.
I feel like it's okay if we just pretend it never existed, but if it's alright, can I ask like a stupid question?
Go for it.
So, can someone like give me a good definition of like non-inducible? Because like I understood the constitutive. Oh my gosh, words. And then I understood, or at least I think I understood the inducible. But would the non-inducible just be the opposite of any inducible, or is there like a totally different definition for it?
See, that I don't know. I got real confused reading through all this stuff, but
I understood that, but that was like 3 days ago.
Yeah.
let me look and see if I can figure out a way to explain this.
Okay, because in my head I literally only pictured it as like the one with the C. Like I only pictured it in my head as like that means on. So like correct me if I'm wrong. I only knew it as that, and then like inducible as like it is on, but like changes under different environmental conditions, and then non-inducible as in like sometimes off. And I got really confused on the non-inducible, especially since a lot of these answers were like non-inducible. So I was just gonna ask this during the meeting, but yeah, I'm not really smart on this part, so I was wondering if any of you could explain it.
Okay, hold on. Let me see.
So
I don't know, because I don't think the notes have anything on it, but
Yeah.
Inducible is like it can be transcribed in certain in different environments. So like constitutive is no matter what, whether lactose is there or not,
Okay.
expressed. But inducible is like even if not talking about lactose, I think like in different environments it's expressed, and then non-inducible is it can't be expressed at all.
It can't be expressed at all?
That's what I understand. Anything else? Does that sound like?
that sounds right for these answers. Like, if non-inducible is it can't be expressed no matter what,
Okay.
Yeah,
and inducible is it can be.
I found
Yeah,
a graph in here somewhere.
I just didn't know if non-inducible was sometimes off or completely off. That's all.
I think it's always off.
Yeah, because
Okay.
basically, so constitutive means it's always on, and then
Mhm.
inducible, it's just the ability of
Inducible is like correct.
it's the ability to produce, I guess the lac operon in different situations.
Like when it needs to.
Yeah, but then non-inducible means it doesn't have that ability. So it can't at all. That's what I understood.
Okay, thank you guys.
Yeah. For sure. Anyways, the last one, I'm not gonna read the paragraph that they have. You guys can go back and read that yourselves because it'll make sense. The LAC-Z gene, if there is a mutation in that, it would also be non-inducible.
Mhm. Okay,
So,
we can just move on to 4 then.
okay.
Yay. I can read it. So this question refers to the Jacob Monod and Pardee experiment. Probably butchered that, whatever. Question A. Why was beta nitrophenylgalactoside or beta ONPG used in this experiment? I'm not gonna read the whole entire thing. I'm just gonna summarize. But basically, beta ONPG is a substrate for the B galactoside, and so when lac operon is doing its thing, naturally the beta galactoside is like produced, and then in order to like tell if it is like doing something, the B ONPG, sorry, is converted into the product, so ONP, and then when it does that, it turns yellow. And so in the experiment, like there was like 3 that were yellow and 1 that was white, and so with that, you with the beta ONPG, you in the experiment you can tell whether or not the lac operon is actually working and doing its thing by the color. So, yay. Question B is basically why was there no color in one of the 4? And that was because, as said previously, the lac operon wasn't working as well as it should, or like it wasn't working because of the absence of lactose, and so no yellow color was observed because, well, in the key it says because of the lac L positive and lac L negative merozygote strain, and so because of absence of lactose again, and so with that, lac L positive gene and the F. What did we say that was? F comma
Prime.
whatever prime. Thank you. F prime plasmid. Together they produce the lac repressor proteins, and then together there's like a double copy, and then it's just bounding to the operators, and then so both of the copies are repressed. For C, what is another method that could be used to measure the level of expression of the lac operon? One could attempt to measure the levels of lactose permease, so the thing that like moves the lactose throughout the cytoplasm, or you could have antibodies be used to detect the presence of any of the 3 lac operon enzymes. So that's that for that one. And then last but not least, why was the optical density twice as high in tube 4 as in tube 1 and 2? In this case, it's because of in tube 4 there was the presence of lactose, and so with that, both of the lac repressors are released, and so there's a double copy of the lac operon and transcription, and so it just ends up being a duo rather than an uno, because nothing's holding them back, and it's like, yay, I'm free to be yellow. Okay, that's it.
I'm sorry, you guys. I'm really, really sorry.
Why?
I tried to mute it so you didn't hear any of that, but
Oh. I just want the dog.
she was fine. They were dancing with her, so.
Oh, she's so cute. Just want her in my life, that's all.
Yeah. You can visit. You can visit.
You need
Number
to.
7, apartment number 7.
At Camden?
Yep.
Okay. I might literally text you and be like, can I come please see the dog?
You're not the only person who said that.
Oh, she's so cute. I love the wrinkles. Okay, let's do number 5. Together, I guess. So, describe how the lac operon is regulated under the environmental conditions as listed in parts A through D below. For this question, it's not It's not sufficient to indicate that the lac operon is transcribed or not transcribed. Please indicate why it will be transcribed or will not be. Okay.
So no glucose or lactose present. So
Under normal environmental conditions, this is just like normal, like a normal lac operon.
This is where they're getting it off of.
heterozygous. So we think that no glucose or lactose present. Glucose, what role did it play?
What?
So what role did glucose play? It bound to something, I felt like. no glucose or lactose. In this case, CAMP levels are high, and the CAMP is bound to the cap protein. This targets the cap protein to the cap site on the DNA. This is a positive signal for transcription. However, in the absence of lactose, the lac repressor is bound to the operator and prevents transcription. Thus, the lac operon is off.
Got it.
It would be off.
Mhm.
So, let me see. I have to make a connection. So what role does glucose play then? Glucose allows, if there's high amounts of or if there's no glucose, then CAMP levels raise. So then the CAMP can bind to the cap site. So the cap protein can bind to the cap site on the DNA.
And it's gonna want to transcribe
But because there's no glucose,
or lactose, because there's no glucose, and that makes it want to be transcribed. But if there's no lactose, also
then the lac repressor binds.
the lac repressor stays on the LAC-O protein,
Okay,
and it can't transcribe.
sounds good.
Glucose present and no lactose.
So that said, in this case, CAMP levels are very low because glucose is present at very low CAMP levels, so that means transcription wouldn't really take place. Since there's no lactose, the lac repressor is bound to the operator, so the lac operon is off because glucose is there, so CAMP levels are low to begin with, and then no lactose there, so that means
What?
The last part was really fuzzy.
Yeah.
So I said there's no glucose, so that means CAMP levels are low, so it doesn't really want to transcribe anyways. But since there's no lactose, the lac repressor is still bound to the operator. So then it's not gonna transcribe. The operon is off.
Yeah. Like, it's not going to transcribe in either case. Like, it's going to, like, doubly not want to.
Okay.
Okay. So then for C, if lactose is present but there's no glucose, the CAMP levels are going to be really high, and so it's going to promote transcription. And then if lactose is present, it's going to even more promote transcription because the lac repressor doesn't get stuck on the LAC-O.
So the lac operon is on.
Yeah.
Mhm.
So it transcribes like super easily.
Yep.
And then is there another one?
Yeah,
There's one last one.
when glucose and lactose are both present.
So if glucose is present, CAMP levels are low. So it wouldn't transcribe. But the repressor isn't present. So
I'm looking at what the key says for that one.
This one is because the CMP is low, the CMP is not bound to the cap. And when the cap isn't bind to the cap site, and the lactose is present, then the lac repressor is released from the operator, and then there's an absence of the positive signal because of the cap binding, or non-cap binding, I guess, and therefore transcription is not occurring.
Because you need both for it to work.
okay.
Yeah.
So it does. Glucose plays a big part in it then.
Yeah.
The what?
Glucose plays a big part in it then.
Mm-hmm.
Okay. Wait, that makes sense. That actually.
Truth.
Okay. And I think that makes connections with a lot of other things that was confusing or that were.
That's good.
I don't know about you guys.
Makes a lot more sense.
Yeah. I like the chart out of everything. Like number 5 was like probably the easiest for me to answer, but everything like 2 and 3 for some reason I was like,
Those ones just took some reading for me to get it. Wait, which chart?
oh no, there wasn't a chart, but like,
Like how it is in that order.
yeah, because if we were to categorize it by like, whether glucose is present, whether it's not, or whether lactose is present, whether it's not, if we were to line it up and then like match it up together, then it could be like easy chart of like high low and stuff like that.
Yeah.
Because last semester I had to learn this thingy, although I totally forgot it now, which is totally convenient. And the teacher gave us like this tiny little chart of like, look, high low, low, high, and all that stuff. So.
Sweet. I feel a little better.
I just feel really bad that Agnes isn't here.
Me too. So in this situation, do I put her name? Because usually I try to like post the link, and then I put everybody's name that was there.
Yeah.
Notice that, but do I not put her name? Do I like?
They do like.
I don't know, because I don't know where she is.
I don't either. I mean,
I thought she would be here by like around 9:30. I thought maybe she would show up, so I was hoping.
Yeah.
I don't know if
I
she
don't
forgot.
know. We can just all comment on it, I guess, and find out where she went.
yeah.
Okay.
And then if she wants to comment on it, then
I can put
whatever.
her name and then say Agnes had other commitments that night. We how do I say it in a way? Because it's not her. Like she would have. It's not like she's flaked.
Yeah, no.
Like try to miss it. So do I say like we're not sure?
I don't know.
Like Agnes.
Like we can. How about like we put everyone's name, but then like for Agnes's, like in parentheses, we can write like absent due to circumstances,
Okay, I can do that.
because then that sounds not too suspicious, hopefully.
Yeah.
But she's not. She doesn't. Like she takes it seriously. So I don't want it to sound like she just flaked out.
Yeah.
Okay, I'll put that.
Okay. Sounds good. Okay, you guys. Till next time.
Well, have a good week.
Uh,
Bye.
Bye.
Bye.